So today I'm going to be talking about other functions and especially how to sketch cubic and quartic functions and to transform their graphs using translations and stretches. So here's a little introduction on cubic and quartic functions. Cubic functions have two curves to them, and they can have three possible intersections in the x-axis. They flow from a negative to a positive, or from a positive to a negative direction. And as I said before, it only has two curves for that. The one that I just drew is actually a quartic function, so it's not a cubic function. So basically, the formula for the cubic function is ax to the power of 3 plus bx to the power of 2 plus cx to the power of, well, 1, but it's not really a 1 because cx to the power of 1 is just cx plus d. We can see that the highest power in this formula is 3, and that a cannot be equals to 0 or else it just turns into a quadratic function. I'm just showing you a cubic function on my GDC and how I graphed it. So now I'm going to talk a little bit about quartic functions. They have this W shape to them, and they pass through the x-axis 4 times. They don't have to pass through the axis 4 times, as you can see on the function on the right. It only passes through the axis twice. Quartic functions also go from a positive to a positive direction or from a negative to a negative direction, different from the cubic function that either goes from a negative to a positive or from a positive to a negative. So the formula for the quartic functions is ax to the power of 4 plus bx to the power of 3 plus cx to the power of 2 plus dx to the power of the ghost 1 plus e. So as we can see, 4 is the highest power to this formula, and a cannot be equals to 0 either, or else it just turns into a cubic function. Now I'm just graphing a random quartic function onto my GDC, and as we can see, the curve is not always very apparent in these functions. So now I'm going to explain a little bit about how you sketch cubic functions in a very descriptive way. We're going to be sketching the function of x to the power of 3 minus x to the power of 2 plus x minus 1. And the first thing you have to do is basically find the y-intercept, and for that you have to substitute x for 0 in the formula. So 0 to the power of 3 minus 0 to the power of 2 plus 0 minus 1. We can see that obviously those zeros are going to cancel out, leaving minus 1 as the answer. Now we just write it down on the corner just so we don't forget, and move on to the next step. Step number 2 is finding the zeros, and for that we have to factorize our function. So we have to factorize x to the power of 3 minus x to the power of 2 plus x minus 1. Sometimes the question will give you the function already factorized so that you don't have to do this step, but if you do this step, there's an easy way for you to factorize. What you're going to do now is split the function in two. So you have x to the power of 3 minus x to the power of 2 in one side, and x minus 1 in the other. To factorize x to the power of 3 minus x to the power of 2, you put x squared outside of brackets and x minus 1 inside of the brackets. We can see that it puts a 1 before the x, just so that we remind ourselves that there's a 1 that we should put outside of the brackets, and then inside the brackets we write x minus 1. Hopefully you will have noticed that x minus 1 is apparent on both sides, so this means that one of your factors is x minus 1. The other factor is the remaining of what's left outside of the brackets, so x squared plus 1. It's always important to go back and make sure you have the right factors, so for that, I'm just simply multiplying out the brackets to correct my answer, which will leave me with x to the power of 3 minus x to the power of 2 plus x minus 1. Now that we have our correct factors, we go back and find our zeros. We simply just need to find the number that in the brackets makes 0. After all, a number times 0 is 0. So that's what we want to find. We obviously know that 1 minus 1 is 0, and x squared plus 1 equals 0, so x squared equals minus 1. However, we know that a square root of a negative number is not a real number, so that leaves us with only 1, 0. As we did with the y-intercept, we also write down the 0 just so we don't forget. Now the last step before we sketch is finding the symmetry point. In this case, the symmetry points will be a coordinate where points between the function will have the same distance from the point of the function and the symmetry point. I know it's a little hard to understand it, but you will understand later when I actually draw it on the graph. So the symmetry points for a cubic function has x as minus b over 3a. We know by looking at our function that a is 1 and b is minus 1, which means x is equal to minus 1 over 3 times 1. We know that our final answer will obviously be 1/3. After all, a negative times a negative is a positive, so it's going to be 1 over 3. So as I said before, the symmetry point is a coordinate. So now that we found x, we need to find y. And to find y, we simply substitute x, which is 1/3, into the formula. We know that when we have brackets, and inside the brackets we have a fraction, and outside we have a power, we simply just make 1 to the power of 3, for example, and 3 to the power of 3. But we know that 1 to the power of 3 is 1, and that 3 to the power of 3 is 27. So we just do that to all of the other fractions, and keep in mind that minus 1 is the same thing as minus 1 over 1. We know that 27 is the lowest common multiple of 27, 9, 3, and 1. So basically you just put all these numbers on top of 27 and just cancel it out. We can see then that our final answer for y is minus 20 over 27. Finally, I'm just going to write down the coordinates for the symmetry points, which is 1 over 3 and minus 20 over 27. And I'll obviously write down in the corner so we don't forget it. Now, please don't get mad at me, because I did correct this later on, but I wrote down minus 20 over 27 is approximately minus 0.75, which is actually minus 0.75, not 0.75. Now comes the fun part where we sketch our graph. And before we sketch, I just wanted to say some quick information about sketching. So when we have a positive a before the x, and when we have a negative a before the x, that's when our graphs will change direction. So when there's a positive a, it flows from a negative to a positive, and when there's a negative a, it flows from a positive to a negative. This is very important to look at before you actually sketch a graph, because that will kind of help you see the graph as you sketch it with the other information. So we know that our x is positive, and that we're going to be using the direction that flows from a negative to a positive. Now is the time when we're actually ready to sketch our cubic function. So now is the part where we start putting in our data in the sketch. We know that y-intercept is minus 1, and we know that our 0, x is 1. So the symmetry points, we also have to put in the coordinates minus 1 and minus 20 over 27. So now we have all of our information, and that is our symmetry points right there that I'm drawing. The symmetry point is very important because we know where the curve is actually going to happen. We also know that the distance from the points between the symmetry points has to be the same on both sides, if that makes any sense. But basically it's very important to have the symmetry points. Now that we have finished and ticked off sketching cubic functions, we're going to talk a little bit more about quartic functions, because it's a new kind of function that we haven't really seen before, and I think it's important to talk about the function before we actually start. So now we have already talked about the formula of the function, and we know that the highest power of the function is 4. We can talk about factorizing the function and graphing the function and its W-shaped graph. And a always can't be 0 or else it just turns into a cubic function. As with the cubic function, it is important to understand what really alters the big shape of this quartic function. Basically, when a is bigger than 0, it will go from a positive to a positive, and when a is smaller than 0, it will go from a negative to a negative. Now very quickly I'm going to be talking about sketching a quartic function. As I said before, they can give you sometimes the function already factorized, which makes it very easier because you don't have to, factorize the function. So we have to sketch the function x plus 2 between brackets, x plus 1 between brackets, x minus 1 between brackets, and x minus 2 between brackets. So as I said before, since it's already factorized, we just have to find the zeros. It is easy to look at this function and already know the zeros. So x equals minus 2, x equals minus 1, x equals 1, and x equals 3. The final step then is to sketch our quartic function. For that we just place our zeros on the x-axis, and the only problem with this quick sketch is that we don't really know how tall the curve will be or how low the curve will be. The fun part now is to cross out sketch cubic and quartic functions.